What will be the value of electrostatic energy when the battery in a circuit is removed and the uncharged identical capacitor is connected in parallel with another capacitor? It's known that when the first capacitor is charged by the battery, the energy stored in the system will be equal to U I is equal half C V naught square, whereas C is representing the capacitance and V naught is representing the voltage. After the battery is removed, an identical uncharged capacitor is connected in parallel with the first one. The total capacitance of the system will change and it can be written as C plus C, it will be equal to 2C. So here we know that the charge is conserved because it's given as electrostatic energy. Whenever we are calculating electrostatic energy, which means the charges are conserved. So which time the C value will get changed? It's known that the formula of C is equal Q over V. When Q is conserved and the capacitance is increasing for 2 times means, of course, the value of voltage is becoming half. That's the true thing, right? So here we can say the value of final voltage will be equal to V naught divided by 2. So energy in a system after the connection can be calculated by adding the energies in both capacitors. So here we can write the final energy will be equal to half C V naught divided by 2 whole power 2 for the first capacitor which we already have in a circuit plus half C V naught divided by 2 whole power 2. This is the capacitor which we added as an uncharged capacitor. So when we are simplifying this, we will get the answer of 1 over 4 CV naught square. So this is our final energy. So when we are comparing the final and the initial energy, we can say the energy was decreased by factor 2. So the correct answer here will be option A.